Yeah, hi Karthik. Is my screen visible?
Yes.
Okay, so let's start with our next session in this ML series. Okay, so in the last session, we have concluded about SVM, right?
Yes.
So in the next, the model we are going to study is called as KNN.
Okay.
Okay, so the KNN is one of the most simple algorithm, I would say. You will just see in today's class how simple it is and still how effective it is. Okay,
Okay.
fine. So first thing, let's try to understand what is KNN. Okay. Right. So if you see, KNN stands for K nearest neighbor algorithm.
Hmm.
Fine. But funny thing is, actually, there is no algorithm in this algorithm. Okay.
Okay.
Because there is no such thing called as learning that is happening actually. Okay.
Okay.
First, let's try to see that basic point. Then you will get an idea. So, firstly, by definition, if you see, a K nearest classifier is a machine learning model that makes predictions based on the majority class of the K nearest data points in the future space. The KNN algorithm assumes that the similar things exist in close proximity, making it intuitive and easy to understand. So what it is saying is this: the basic approach of this algorithm is it will give you the prediction. So ultimately, again, this is also a classification model. So that means we are using it for predictions only. Okay, that point, that part is clear.
Okay.
So, but here the predictions are based on the majority class of the k nearest data points,
Mm-hmm.
right? So now k here is a number,
Okay.
right? So that is an hyperparameter,
Okay.
right? That means what you can tune that and find out the best value,
Okay.
right? Whenever we say hyperparameter, that means be- there is no fixed value. Okay, you can tune and find out the best value. Just like in previous session, we have seen SVM-C hyperparameter.
Yeah. Yeah. Yeah.
So by default, it might be one, but it's not no rule that it should be always be one. Fine. So
Okay.
here also
Okay.
we don't have any by default value here k. So you need to test and find out which is the best k. But the point is what it will do is that there is no formula, there is no max, there is no calculations or functions, anything.
Mm-hmm.
Based upon the majority of the class, it will tell you the prediction. Okay.
Okay.
So it will why it is saying, because it one fundamental thing it will assume is similar points lies near to each other.
Okay.
Okay, so you see normally we have this proverb in English, right? So birds with same wings flock together. So
Mm-hmm.
we have that means like similar birds fly together,
Yeah.
right? So that means if two people are okay traveling together, that means there will be some similarity between them.
Yeah.
Similarly, here also he's saying which like our test point, whichever you are wanting the prediction, right? So it will just find out the similar points for the test point, and based upon the measure, it will give you the prediction.
Hmm.
Okay, so this is the fundamental point. So now, if you see, what happens is I will just give you a basic example. So, but before that, note that k is the number of neighbors that we consider. Okay,
Yeah.
so if I consider k equal to 3, that means I'm saying, hey, consider three nearest neighbors,
Mm-hmm.
and from that, check the majority. Okay, so that means, for example, what it will do is basic idea is very, very simple. So you are having, uh, for example, if you take note this, you have some Titanic example, right? So in
Mm-hmm.
that, what are the two output classes, 0 and 1?
Yeah.
Okay, so we are only two classes. Fine.
Yes.
So let's say you have like 10 data points. Fine, 10 data points. So you will plot all the 10 data points.
Mm-hmm.
Okay, so let's say in this 10, 7 are uh, zeros and 3 are ones.
Okay.
Okay, in 10 data points, you will plot this 7. Okay, let's say you are having only two features. For simplicity, consider there are only two features. Okay, and you are plotting the 7 points. Okay, let's say these are falling somewhere here. Okay,
Okay.
5, 6, 7, and these three
Mm-hmm.
ones are falling somewhere here. Okay, now
Okay.
these are the complete data set we have plotted.
Yeah.
Okay, training data set or whatever the data set you have plotted.
Mm-hmm.
Now what I'm saying, now I am bringing a new test data set, and I'm saying, hey, this is my new test data set. Tell me what is its prediction. Same problem which we are trying to solve, whether it is
Okay.
0 or 1. That is what called prediction, right?
Yes. Yes.
Fine. So now what it will do, it will just take this point. This will also have two features. Let's say this is x1, x2. Okay. So this could
Yeah.
be age, this could be gender, any two features.
Hmm.
So here also the new test point will also have those features x1,
Yeah.
x2. but we don't know its prediction, whether it is 0 or 1, we don't know.
Correct.
Correct? So what we'll do, we'll just take this and plot here. So let's say it is falling somewhere here.
Okay.
Okay, based upon the x1, x2 values. If x1 is this much, x2 is
Yeah,
this.
yeah. So it will predict like
Yeah.
near
So
to.
now, I
Yeah.
will say k. Now data
Hmm.
is plotted. So I will say k. Now k, for example, I will start with 3. That means
Mhm.
what? It will consider 3 nearest points. This is 1 nearest point. This is second nearest point. Let's say this is third nearest point.
Okay.
Okay. So out of these 3, how many are zeros and how many are ones?
All are zeros.
All are zeros. So it will say, hey, this prediction will also be 0.
Okay.
Because why? So because you are saying, telling k is our job.
Hmm.
Giving up the majority thing is algorithm job.
Yeah, yeah.
Okay.
So,
We will say 3. So it will say out of 3, what I have considered, all 3 are safe. Okay. For example, let's say our data point is falling here.
okay.
Okay. So
Mhm.
then let's say 1, 2, 3.
Mhm.
In that, what we have 2 zeros,
Majority
1,
is
1.
no,
Majority.
no. Two ones. Two ones.
Okay. 2, 1. These are ones. Right. 2
Yeah.
ones and 1 0. So
Yeah.
it will say, hey, 2 is my prediction.
Okay.
Sorry, not 2 is my prediction. 1 is my prediction.
One is yeah.
Correct. So that's what it does.
Yes.
So
Got
just
it.
calculate the majority and it will give you.
Okay.
So here you don't see any equations like logistic or planes like SVM, nothing.
Got it.
Okay, very simple algorithm. Clear the basic idea?
Yeah.
So now it's called KNN. Why? Because K is a hyperparameter, that is the number of nearest neighbor. NN stands for nearest neighbor. K
Okay.
is the
Number.
value of K. So if you're having K equal to 3, it's called 3NN.
Okay.
3 means 5NN. 5
Okay.
nearest neighbors, I'm considering.
Okay.
Okay, fine. So now even though this seems very simple, but this is very effective. For example, in my current job, in the current project which I'm working in my company, right? So we are using this model.
Oh.
So
Okay.
my problem statement which I'm trying to solve is, it's called planned recommendation. That means
Mhm.
we need to recommend healthcare plans,
Okay.
right? Two different people. So what it will do, we plot all the existing, let's say from last 3 years or 4 years data sets, we'll plot it. Now a new person will come, okay,
Mhm.
with his requirement. So we will just plot him and we will see the nearest persons. Because if this person is saying, okay, I want, for example, premium should be less than 100, and I also want, for example, this particular doctor, I want in this
Mhm.
location.
Mhm.
When I'm plotting him,
Mhm.
the nearest persons, wherever he's getting plotted, the nearest people are similar persons, because they are also having similar requirements, right? So that's why they are nearby.
Yeah.
Getting?
Hmm.
For example, this dimension is, let's say, premium, how much premium he need to pay. This dimension is, for example, let's say whether some particular doctor is looking for. There is some other dimension like how much, whether it is covering ambulance bill or not. Example, okay.
Yeah.
We are
Yeah.
getting 10, 100 patients, okay, trained data from last 2 years, 100 patients data we have plotted. Now, a
Correct.
new person who is coming with this requirements, if he is falling here, okay,
Hmm. Hmm.
two persons are very nearby. That means what? Already, whatever this orange point from our training data, whatever the values he's having, like premium, let's say he's paying only 50, 500 monthly, and he's using ambulance and also particular doctor. If our new data point is getting plotted very near to this person, that means these two features are very similar.
Correct.
Correct? Because
Yeah.
only when the features are similar, that means this X, Y, Z dimensions are similar, they will be nearby.
Hmm.
So then we will consider like that, let's say 5 or 10 or k equal how much value we'll consider, and then from that we will give the best plans for this particular person.
Okay. Plans. Okay.
Okay. In that case,
So
as
yeah,
of now in our
based.
project,
Mhm.
complete this. As of now in our project, we are using k equal to 30.
Oh. Okay.
This is an example. So we are considering 30 similar
Got it.
persons for the input person, and
Mhm.
based upon that we are recommending him, and we will see. So in these 30%, we will see what all plans they considered.
Okay.
All these 30% are historical plans, historical people, right? We already have that means they are
Yeah. Yeah.
into some plan.
Correct.
Each person will have two plans.
Mhm.
Okay. So now this person is a new guy who want to take a new plan. So we'll consider k equal to 30. That means 30 people and each person two plans. So 60 plans we have,
Mhm.
right? Which are very similar to our new test person.
Okay.
From that 60, we will do some processing and we will give him top 5, top 6. That is the basic project which you are working. So why I'm telling
So
here is, even though it is very simple, so it is very effective. Yeah.
so we need to provide best plan. I mean, we need to suggest him the best plan.
Best plan.
Okay.
Best plan. Right.
On what basis we will take k value?
Correct. That we will see. So
Okay.
that we need to test and experiment and see.
Okay.
Okay. So that
Okay.
we'll see. Okay. Yeah.
Yeah.
But that is a basic way how we are doing. Okay.
Okay.
Fine. So now coming to this so K is a number of neighbors what we are checking. Okay. And also one thing is K, this algorithm usually called as lazy learner. That means
Yeah.
what? It is not learning anything, right?
Correct.
For example, if we have logistic regression, we have an equation.
Correct.
WX some equation. SVM also we have a plane.
Yeah.
That means it has learned that, right? How it is learning? So using the gradient descent, we have optimized it and we got the best parameters. We have
Yeah.
decreased the loss. Finally, we got a line equation.
Correct.
Correct. In linear regression also it is, we had a line equation,
Yeah.
right? With minimum loss, minimum distance, etc. RMSE, some error. Okay.
So here we don't like,
We
it's
don't
not
learn.
related
We
to
are not
anything,
learning
line,
anything.
nothing. Yeah. Yeah.
There is no equation
Correct.
because there is no learning, right?
Correct.
So that's why it's called lazy learner. Means it does not actually learn anything from data. From data, it is not learning anything.
Correct.
Whatever you give data, it will just keep with it.
Yeah.
Only when you're asking for a prediction, then it will use the whole data. It will plot your data set, check the K, and give the majority prediction. That's it.
Yeah. What are the use cases for this? I mean, when exactly we need to use this KNN?
There are many use cases. For example, see,
Mm-hmm.
if you think about it, so if you, for example, it is trying to find out the similar persons.
Okay. Yeah. Got
Okay.
it.
Now, if you just see, there are many examples in our day-to-day life. For
True.
example,
True.
you like a particular movie. I like different movie. Now, KNN, let's say Netflix or Amazon Prime, if you have like 1,000 people movies there, if they take your cache data
Mm.
and see which
Mm.
genre you are liking, and each person will become one data point for them. And they will
Correct.
plot it. And
Correct.
when new person is coming, if there are any similarities, this person is liking horror plus romance, etc., then you will fall into that bucket.
Yeah.
Then they will start recommending the one case.
Yeah. Yeah. In YouTube, for example, if you are
Correct.
regularly watching any video
Yes,
similar to
same
this,
thing you will get.
it will give
In
some
Insta, you
same
see one
videos.
post, everything
Correct.
follows.
Correct.
I'm not
Correct.
saying all those are using KNN, they will use
Correct.
more advanced, but
Hmm.
there is one use case you can think in that line.
Yeah.
For
Okay.
example, you apply for a loan.
Mm-hmm.
Okay, whether you will repay or not, the bank doesn't know. So they
Correct.
will do some testing. Okay, then they will see the person similar to you. That means what?
Mm-hmm.
Your age, because they already have past customers, right? Who has took the loan and paid perfectly. They will
Correct.
try to match like people like you, like age similar to Karthik and salary near to you, okay,
Mm-hmm.
and job or your company which level. So all these 4 5 dimensions features they will take, and then they will analyze that and they will put you in that bucket, and we'll see in that how many people are able to pay.
Mm-hmm.
So you will become a similar point for them. So that is K. You're also becoming one of the nearest neighbor to them.
Correct. Yeah. We have
Getting
many use
like that,
cases.
many
Yeah.
you can think. For example, loan is one example, and how much income should I give you? Okay, so you can take 4 5 features: my IQ level, my education, my etc. for 10 people, and new person if is coming, you can say averagely we can give this much.
Correct. Also,
Okay,
we can give term insurance, for example,
term
health
insurance,
insurance
right, right.
suggestions based on age,
Yes,
salary, and place. Yeah. Okay.
yes, right. So like
Yeah.
that, we can think of many examples,
Mm-hmm.
right? So it is just finding a similar person, and I think in today's life, most of what we are doing, right, it's just in the background, it's just pattern matching that is happening,
Correct.
right? Most of the thing in YouTube, we will see that means it is matching our pattern, right?
Yeah.
We get customized advertisements we are getting, right?
Correct. Correct.
Right, and also some advertisements will get only in the morning, some you will get only in the night,
Yeah.
some
Yeah.
only
Yeah.
on weekends,
Yeah.
some only to particular people. Okay, in some phones you will get, I think in iPhones you will get some advertisements, in Android like that. It is always trying to find out similar people
Yeah.
like you.
Okay.
Okay.
Yeah.
Fine. So now since we understood, so how exactly this works, we'll see. Okay. So one is measure the distance from test point to all the points. Okay. That means what? When you have given this distance, you have asking for this point. Okay. New point.
Yeah.
Okay. For example, these blue and pink points are already there. So for this orange point, you are asking, or let me take this color. Okay. So this is a new green color for new test point. You are asking for that. So what we will do? Simple. We will consider this point and we want the closest. How will you get the closest? We will calculate the distance from this point, test point, to all the points. Okay. From this point
Yes.
to this point, this point, this point, this point, all this point. And then
Majority.
sort it in the, ascending order.
Yeah.
You will get the closest points, right?
Correct.
Right. Find out the distance first is, next pick the closest points. Okay. And now if it is classification, you'll go with the most common class. That means majority class.
Mm-hmm.
If it is regression, you will take the average value of those values.
Okay.
That means what? For example, all these 10 people. Okay. Now this is not a classification. Let's say all these 10 people are house prices. Each data point is one house.
Okay.
Okay, and now you put the point here, and let's say these 4 points are k equal to 4. Now, what you will do, you take the 4 and you do the average of all these 4 prices. That will become your point average value.
Okay. Okay.
Okay, regression. But it's a classification, you'll go by the majority class.
Okay.
Getting?
Yeah.
Fine. Now, when I say distance, right? So we are calculating the distance. So there are different ways to calculate the distance. Okay.
Okay.
The basic distance is called as Euclidean distance.
Mm-hmm.
Okay. And we have other distance also called as Manhattan and Minkowski distance. Okay. By
Mm-hmm.
default, we'll use Euclidean. So, for example, if you see what are these distances, yeah. So, just I was checking on that. There are many distances, but mainly we'll use three. One is Euclidean distance. That means the straightforward distance.
Mm-hmm.
Okay. If you have 2 points, the basic distance how you'll do this is x1, y1, x2, y2, square root of x2 minus x1 whole square minus y2 whole square. Distance between
Yeah.
two.
Yeah.
Okay, x1 minus x2 whole square. This is the direct distance. Okay. Now
Correct.
then you have this is similarity distance, but what was other distance? This is Manhattan. Okay, Manhattan distance is it's called cab distance. Okay,
Mm-hmm.
so in Manhattan is a place in I think US. Okay,
Yeah.
so there, for example, you are here, I am here. Okay, Euclidean distance. If you want to meet me, okay, we can directly meet here like this.
Correct.
Okay, but that is possible only
Also,
both are in air.
yeah.
Okay, yeah, both are traveling in air, but in road we cannot do this, right? So you need to first travel this line, this road, and then come to this road.
Okay.
Okay, considering US roads, our Indian roads could be like this. Okay, that's a different matter. Okay, but
Mm.
if it is a perfectly planned city, then you will have all roads in the perfect square or rectangular manner, right? So in this particular way, so this will be the distance from you to me, from A to
Okay.
B.
Yeah. Only in the right angular.
Yeah, this way.
Okay.
Okay, you see this one. This is this distance plus this distance is the Manhattan distance.
Yeah. Yeah. Got it.
Okay? And there is one more distance called as Minkowski. So that is I'll show you here. So one is Euclidean basic Manhattan. Minkowski is a distance, but it's not a special distance. For example, this is a formula. If
Mm-hmm.
you have Q here, right?
Yeah.
You put Q, sorry, P or Q. Okay, if you put Q equal to 1, okay.
Yeah.
If you put 1, what will happen? 1 by 1, this will become 1.
Same.
This will
Again
become
one.
this mod of x1 minus y1, which is same as Manhattan.
Correct.
Okay, so when Q equal to 1, it will give you Manhattan. Okay, and for example, if you Q equal to 2, that means this will become 1 by 2 and this will become 2. Okay,
Hmm.
1 by 2 means this is square root.
Correct.
Okay, square root can be written as whole power 1 by 2, right?
Yeah. Yeah.
And inside
And it will
square, so this
give
has become
Euclidean.
Euclidean. Okay, so Minkowski is a special, not a special, but it is a generalized form of distance where giving 1 give Manhattan, 2 gives Euclidean.
Yeah. Okay.
Okay, fine. But usually we go with the Euclidean distance. As I said, even in our project currently also we're using Euclidean distance.
Okay.
Okay, but the fundamental thing is any distance you take, calculate the distance from our test point to all the data points and choose the k nearest points, go with the majority.
Okay.
Okay, but that is simple, but there are few points, few logics we need to consider. Okay, so that you will have better understanding. Fine.
Okay.
So now there is no, but how to find out k?
Mm.
You know, I would say unfortunately there is no direct rule to find a k, optimal k. Optimal
Okay.
k is the best k in KNN.
Yeah.
Usually we do it with explore and experiment, and from this explore and experimentation only we have a new concept called as cross validation that we'll
Okay.
study later. Okay,
Mm-hmm.
why we'll study, we'll see that, but how we'll explore and do some experimenting, we'll see that. But usually what happens with k is one thing very interesting. If you see here, these are red points, these are blue. Okay,
Yeah.
that means these are classes. Red is one class, blue is one class. Clear? In
Yeah.
red we are having 4 data points, blue is 4 data points.
Yes.
This could be any class. Let's say this is red is saying spam mail, blue is saying not a spam, or red is saying he's a don't give loan to this person. I don't know use case, but those are two classes I'm saying.
Yeah.
Getting?
Yes.
Now, if my data point is here,
Hmm.
now when I say k equal to 1, the nearest point is red. So this will be classified as red. Because k equal to 1, only one nearest data point I'm saying.
Yes.
So this will now this will become red. Okay.
Hmm.
But if you say k equal to 3, what happens? This is my first nearest point, this is second nearest point, this is third nearest point.
Correct.
The majority is blue.
Yeah.
So this will become blue. But if I go for k equal to 4,
Hmm.
these two.
Yeah.
So 2 red, 2 blue. Now what will the classification?
No, it's not properly.
Not proper, right? Correct.
Hmm.
So when you are having that way, it is not uh, this is 2 red and 2 blue. Okay, so it is not properly defined.
Yeah.
Okay, so that's why we have few rules. Okay, but before that, yeah. So in Iris dataset also, just to give a practical example, let's say you're having 3 classes, right?
Yeah.
So one is Setosa, Virginica, and versicolor.
Versicolor.
Okay, you are plotting all these data points. Now, given a new data point, if it is plotting here, so you can do with k equal to 3. If you 3, 5, 7, 11, 13, anything.
Mm-hmm.
Okay, so like that you can check it. Okay, we will see that example.
Okay.
Uh, but before that, few theory points we need to consider. Okay, so for example, if you see, since k does not learn any pattern, it uses the whole training data set for any new query from test set. So we get affected by time complexity and space complexity. That means what the same concept what we studied is, since it is not learning anything,
Yeah.
it is doing, it need the whole training data set.
Correct. It will take huge time and space
Huge
as
time
well.
and
Yeah.
space. Correct.
Yeah.
Space
Yeah.
why? Because it need to deploy the complete training or whatever the training data you
Yeah.
are,
Yeah.
right?
Yeah.
It need to
Data. Yeah.
deploy that whole data. Okay.
Correct.
But when you compare it with logistic regression, we only just need that one single equation.
Correct.
Parameters of W and B. In SVM also, just what is the plane of the equation? One single equation. Might be 1 byte or 2 byte of information is enough.
Yeah.
Correct? But with that only, whatever the new data point, you will do the prediction. But here it's not like that. The complete whatever the, for example, if you're having 1 GB, 2 GB of training data, it need all that data. You need to deploy that in your cloud or local or anywhere. Okay, which requires huge space. One thing. Secondly, after that, when you pass a new test data set, again it need to calculate that distance from all the 10,000 or 10 lakhs data points and then find out the distance.
Yeah.
That will take more time. So usually we face these two problems: space complexity and time complexity. Agree?
Yeah, Santosh.
Right. So now we are going to see few pros and cons. Okay, one is it's very simple. Okay, no training time because there is no training that is happening. Agree?
Yes.
Works well with low dimensional data. Why? Because if you're having high dimensional, again the complexity will increase. Okay, because it's slowed prediction because it need to compute all the distances to all the training data points. So that's why if the data is more, it is a bit difficult. Sensitive to irrelevant features and feature scales. As I said in our previous session, any model which is involving distance, you should be careful with the scaling.
Yeah.
Correct? So here also, because we are calculating the distance, so first the feature should be scaled.
Hmm.
Okay, that's and doesn't work well with large and high dimension, because if it is a very large, right? So calculating the all the distances will take huge time. So that's why usually with large dimensions data, it's not preferred.
Okay.
Okay, fine. So are we good till now? Did you understand the basic logic?
Yeah, Santosh. Clear.
Clear, right? Okay. So and by default,
We consider Euclid
that's a
distance.
Euclidean distance.
Yeah.
Okay, but you have other distance also. But
Hmm.
you know what happens if you choose very low k, and what happens if you choose very high k? We'll see. Okay, but before that, usually what should be the value of k? We'll see that. Okay, yeah. So usually the value of k, if you want to take some number, you can take square root of the number of rows in training data sets. Okay, if you just want some number which will work, okay. If you're having, let's say, 1,000 data points,
Mm-hmm.
the square root of this 1,000, that number you can take it as k.
Okay.
Okay, fine.
Mm-hmm.
And but if you don't want that, if you want more better way, then what we do is you usually start with some range and start checking the accuracy.
Okay.
Okay, start checking the accuracy. That means what? You divide it into training data and not training data. That means you put some data as, yeah, yeah, correct. So you divide into training data and test data. Okay, we take this training data, but we cannot train anything. Okay, because there is no training here. Okay, keep it aside. Now you take the test data, fine. So now you decide, start with some k. Let's say k is ranging from 1 to 30 or 20, for example. Okay. First take k equal to 1 and pass each of this data set from here and find out its corresponding value from the training data set.
Okay.
Getting? Not getting?
A little confused.
Okay, fine. See what is happening is, let me open any example, then it will be better. Okay, Titanic. Okay. See here, what is happening here is, this is my data set.
Yeah.
Okay, and survived is my column. Okay, I'll just put it at the last. Okay, this is my output column.
Correct.
Right. So now what I'm saying is, in the whole data set, divide it into train data and test data.
Correct.
This will become train, this will become test.
Yeah.
Okay. Take and save this training data. Because there is no training, just save it somewhere.
Okay.
Okay. Now come the test. So what you will do, you will just take one row. Okay. And consider some k equal to 3, for example.
Okay.
Now you are plotting this training data, because always remember the predictions are coming based upon the training data only.
Correct.
There is no training happening. That is okay. But what are the predictions you are getting, right? So that are based on the training data.
Yeah.
So now let's say you are 25 rows which you are having. Okay. Those you are plotting.
Yeah.
Okay. And some will be in some color and some will be in another color. For example, because you are having two classes, 0 and 1.
0 and 1. Yeah.
Let's say these are zeros and these are 1.
Okay,
all this 25 you have plotted.
Yeah.
Okay. Now what I'm saying, now take one row from this. Okay. And plot here.
Okay.
Okay. Let's say I'm plotting here, my new test data point.
Yeah.
Okay. I know its corresponding value.
Yeah.
0, but I'll not use that. Now I'm saying, hey, this is my training data. This is my test point. Use k equal to 3 and tell me what is the prediction.
Yeah. Correct.
Getting? Based upon that, it will say 0 or 1. Let's say it said 0.
Okay.
Like that, you will do it for all the data points.
Correct.
You will get some accuracy.
Correct.
Put it aside. Next, do the same thing for k equal to 4. Now, when you use k equal to 4, this will change, because
Correct. Definitely.
earlier there might be some shuffling and 0 might become 1, 1 might become 0. Correct?
Yeah.
Like that, you repeat from k equal to, let's say, 3 to 30. Run a loop. Okay. And find out the accuracy. In that, go for the k which is having the best accuracy.
Okay.
Got it?
Yeah. Why 30?
It's a random number. Usually, that's a good question. But usually, in what I have seen also, we test usually till 30. There is no, 100% rule why we use. But usually, we don't go for a very high value of k, like 60, 70. I have not seen. I'm not saying no. But considering 70 data points, because generally speaking, if you consider like 30, 40 people,
Yeah.
you will get
Some accuracy. Yeah.
more or less. If you are like, if you talk to like 30 people who know you, mostly we can get to know what you are, right?
Correct.
Similar
So,
concept.
what might be the data volume? I mean, data.
Data volume, it depends on the project, right?
Yeah, in general, because this is, I mean, this is not like, for example, we should accuracy should be more. Okay, I mean, it's not like, for example, we have he's a cancer patient or not. I mean, we should not easily take this algorithm for that example, right? I mean, what might be the case? So that's when, without just having a rough example like 30, 20. Yeah, I mean, just for use case purpose. Yeah.
Okay. See, for example, in our case, we are having something around few lakhs of rows.
Oh, okay.
Few lakhs of rows. Okay. So that's it takes much time. It used to take like 3 to 4 hours of training.
Oh.
Yeah. So that way.
Okay. So
but once you train, and you reach, see, this is one time. See, the point is, for the very first time, you need to start from 3 to 30.
Okay.
let's say you got 25.
Mm-hmm.
Okay. Now, next time, if you, after 1 month, if the data is updated,
Mm-hmm.
right, you don't again need to start with 30, because if it is 25, it will be somewhere around 25, right? So you
Yeah,
start from 20 to 30, or
okay,
mostly 23 to 28.
got it.
Okay, you can test this, because if it is 25, small changes will shuffle just here and there. So you
Yeah,
don't need to again go for the whole stretch.
got it. Also,
Okay.
training is also like 80-20% only, right?
Yeah, 80
Same,
20%.
same. Yeah, same.
Yeah.
Okay.
But no, not always. But because in our case, we are doing 90-10.
Oh, 90-10.
Yeah.
Okay.
Because here, the point here is the more training data, the better. Because there is no training that is happening, right? It is only
Correct, correct. We
depending
have to
based on the
train.
training data. Because if you, the more training data you provide, the better results it will give you.
Got it.
Okay. So that's why
Yeah.
we gave 90-10.
Understand.
Clear?
Yeah, clear.
So one is the range, you can go by square root. Second
Mm-hmm.
thing, sorry, one is you can go with the range of values like from 1 to 30 and do
Yeah.
the looping and find out the accuracy.
Mm-hmm.
Second thing is, or for simplicity, you can go with the square. Sometimes it work.
Mm-hmm.
Third thing is very interesting point. K should be odd number deliberately to avoid ambiguity. That means what? So if you're, yeah, so if you are having,
Yeah, yeah. Before means there might be two case.
exactly. So if you're having these data points, correct? So this is some other data point, and I'm having this point. So if I use k equal to even number, just now
Mhm.
we have seen, right?
Yeah,
This case.
yeah, yeah.
2, 2. If you're having 1, 1, if you're using k equal to 2, and if this is 1, then we cannot.
Correct.
If k equal to 4, then if it is 2, 2, then we are stopped.
Yeah,
Agree?
true.
That's why we want, there is no rule, but to avoid
Got
the scenario, we deliberately go with the odd number.
Okay.
Okay? Fine. And also when you are looping from k equal to 1 to 30, it will take till 29.
Oh, in
In
exclusive.
range,
Okay.
right? When you are doing range of 1
Mm-hmm.
to 29, it will take 1 to 29. Okay. Yeah.
Okay.
That is one thing. And second thing, it should not be, one is not a odd, should be odd number. And also not every odd number, because it should not be also multiples of labels. That means what? See, you are having this, let's say you are having one more color. That is, for example, this pink is Setosa. This is Virginica. And now blue is, let's say, Versica.
Vaccine. Mm-hmm.
Okay. Now there is a data point. Green. I am putting it here.
Mm-hmm.
Okay. Now let's say I used k equal to 3.
Mm-hmm.
Now one nearest point, one nearest point, one nearest point.
Okay.
Now I use k equal to 3. One nearest neighbor is coming from Setosa, one is from Virginica, one is from Versicolor.
Oh, okay.
Getting? Now k
Yeah,
is
yeah.
not even, odd only, but still we are not able to decide,
Because of labels.
because this k equal to 3 is the multiples of number of neighbors. That means what?
Correct.
Number of labels equal to 3, all these multiples like 3, 6, 9,
Got it.
12, it should not be this.
Yeah, yeah, got it.
Correct?
Yeah.
Because if k equal to 9 we are doing, and if 3 from each you are getting,
Mm.
3 from Setosa, 3 from Virginica, 3 from Virginica, it might rarely happen, but if it happens, then again, it cannot
True.
decide for the data points.
True, true, true.
Getting the logic?
Yeah, yeah. Understand.
Right. So that's why we usually follow these rules. So it should not be odd and it should not be multiples of the given labels.
Okay.
Okay.
Yeah.
So that is regarding the K, how you will find out and how you can start with. Fine. So we have seen the basic idea and we understood the value of K, and yeah. So one more point we'll see is what if what happens if we take the very low K value and what is the high value? Okay. So if you are using the very low K value, the lowest K value possible is 1.
Mm.
Can you tell me what is the highest K value?
Infinity. We can give whatever the data points. I mean, testing
Correct.
data points.
Exactly. Perfect. So if you're having 1000 data points, we'll consider all 1000.
Yeah.
Okay. So now if you take K equal to 1 as low, that means what? We are looking very narrowly. The nearest data point itself we are finding.
Considering. Yeah.
Okay. If there are any slight changes to the data points, our output will change.
Mm.
Correct? So
Yeah.
that's why what happens is when you're using k equal to 1, means we are looking very narrowly. That means what? We are overfitting actually.
Okay.
That means
High variance.
very sensitive to change in the input data. That means to this input data, it will work. Okay. But if there are any slight changes, it will not work. So it is very overfitting.
Got it.
Okay. That means what? It will work well for this data set, but in test data set, it might not work.
Yeah.
Now, if you go for the other extreme, which is k equal to n, that means if you're having 1000, so I'm saying k equal to 1000. So what is happening here? Here, there is no need, since we are using all the 1000 points, we are doing nothing. We are just considering all the data points and we are going with the majority of the class. In the 1000 data points, what is a majority class that is repeating?
Yeah.
Correct? That means if it is 1000 and if there are 700 people are Titanic example 0, 300 are 1. If you are using k equal to 1000, that means whatever the data point you give,
Yes.
the answer will always be 0.
Correct.
Because for every data point, you need to consider 1000. You're getting this point. This is
Yeah.
very
Yeah. Yeah.
useful.
Understand. Understand.
Okay? If you go with k equal to let's say 20 or 30, sometimes the output could be 0, sometimes it could be 1 based upon the majority. In that k equal to 20.
Okay.
25, if you take, there will be some changes. Okay.
Correct.
But again, there are chances because every time you are considering only 25 nearest neighbors. And in that, sometimes the 0 could be majority, 1 could be majority.
Yeah.
Getting?
Huh.
Correct? Because if there are here all zeros, what zero class data points are settled. Okay. Here all
Yeah.
one data points are settled. Now, luckily, for example, even though these ones are 700, zeros are 300. Okay. If your data set when you're plotting, luckily if it is falling here, the nearest data points will be zeros.
Correct.
So it will tell you the output is 0.
Yes.
Even though overall data set majority is 1,
Hmm.
but in the closed circle of k equal to 20, which you have considered, there are possibility that some of the data points can give output as 0.
Yeah.
Getting?
Yeah. Yeah.
But now if you make this k equal to the number of overall data set, that means 1000.
Hmm.
That means for every data point, you need to consider all the data points.
Correct.
That means what? You don't need to think about anything because if you consider whole data point, the 0 class is always the maximum. So the
It will
value
give always the same. Yeah.
always 0.
Yeah.
Correct? Even though it is very, very near to 0 point also,
Correct.
you need to consider everything. So no need of seeing anything directly. The value will always be 700. Is
Yeah.
this point clear?
Yeah. Clear.
Okay. So that is also not a good thing, right?
True.
That
True.
means there is
Underfitting.
something.
Underfitting. Yeah.
Okay. So here we are looking very broad. Fine. So no low variance, whole data is considered. Consider all data points. So no classification. So we just go by the majority, which is underfitting. Okay. So k
Hmm.
equal to very low is also not a good thing. K equal to very high is also not a good thing.
Yeah.
Okay. Then you need to loop through, find out the accuracy and find out.
Okay.
Clear?
Clear.
Okay. Yeah. So distance part is done and we have seen the example pros, cons and k equal to 1. Yeah. So here what happens if you choose very low k, if k equal to 1, what happens? It's very sensitive to noise. That means even a slight change also there will be a problem. It might overfit.
Yeah.
If you slowly increase k equal to 3 or 5, okay, slowly it will start understanding the local patterns, but still there might be some overfitting.
Yeah.
If you go with a bit high k, it will look more at the neighbors, but it might start underfitting.
Hmm.
If you go with the overall data points, then it just predicts majority class for all the data points, no learning at all, just majority vote. That means fully underfitting.
Yeah.
Okay, fine. Although this works for 2D, you can easily extend for other features also. Okay, even if it is 3-4 features also, you can plot in high dimensional. Okay, fine. And these are the major points actually, I would try to say.
Yeah.
Yeah, so but yeah, this is one of the main important points. We usually not find this in any of the tutorial, but in some tutorial I found this, and this is a very interesting point. Here, if you see, when we are saying KNN, K is one part, NN is one part. From where we are getting K, from where we are getting NN, it is very interesting to understand. See,
Mm-hmm.
K is what? K is, I'm saying, K is the number of nearest neighbors, the best number of nearest neighbors,
Yeah.
which is working. That means what? If I'm having, for example, if I go here, okay, if I do this, yeah, we did this, right? So now over here, I have tested for this test data points, let's say 10 data points, and I am checking. First, I'm starting with, let's say, my range is assumed from 3 to 10.
Mm-hmm.
Equal to 3 to 10, I'm testing. That means first I will take 3. I will test for all these 10 data points. And next I'll go with 4, test again, 5, 10, like that I will test.
Okay.
Agree?
Yeah.
And in that I'll choose. But now the the training data set is fixed.
Yeah.
But if I start changing the test data set, okay, what
Mm-hmm.
see the point here is whatever the k I am getting, right? So that is just it is saying for the given test number of data sets, for how many data sets you are getting a actual prediction equal to predicted prediction. Okay, see what I mean here is, let's say you consider k equal to 3 case.
Yeah.
Okay, initially k equal to 3. With that,
Mm-hmm.
you are testing all these 10 data points,
Correct.
and then you are checking how many of the actual predictions are matching with the predictions from the model.
Correct.
That means what you are getting, right? Each data point you will
Yeah.
take
Yeah.
and
Yeah.
see as per the training data and as per the k equal to 3, what is its prediction?
Correct.
Like that, you will do for all 10 points.
Correct.
And if like 8 points are we are getting, that means let's say my 80% is accuracy.
Hmm.
K equal to 3.
Hmm.
Next, I'll do for k equal to 4. There is some
Yeah.
accuracy.
Yeah.
Finally, I will go with the k which is giving the best accuracy.
Correct.
But the point here to note here is, more importantly, I am just seeing out of all these 10 data points, how many of them are for how many data points it is doing justice.
Hmm. Correct.
Correct. Now, if
Correct.
I change this data set,
Mm-hmm.
this will change because if I use 10, it is working. Now, for example, in 10, I am adding 10 more data points. Now, there are 20 data points.
Yeah.
K equal to 3 only.
Yeah.
Now, using the same k equal to 3 for 10 data points, if I'm getting accuracy, I'll go, if I add some more data points for k equal to 20, this might not work. K equal to 3 might not, again, we might not get 80% because for
Correct.
new
Correct.
data
Because 10
points,
data
it will
points
change.
added extra. Yeah.
Correct? So that means what? Our k is dependent on the test data set.
Correct.
Getting?
Correct.
That is very important point. So k is dependent on test data set.
Yeah.
If you change the test data set, the performance of our k is varying and your accuracy will also change.
Correct.
Correct?
Correct.
Fine. That is k.
Hmm.
Now coming to NN, what is NN? NN is the nearest neighbor.
Yeah.
Nearest neighbor means what? How many nearest numbers the nearest neighbors are coming from where? My
Test.
training
Set
data set.
training data set. Yeah.
Correct?
Hmm.
This is my test data set. I am saying, hey, find out k equal to 3. This
Yeah.
k this is dependent on the test data set. But when
Yeah.
I'm saying 3, that 3 data points are coming from where? From test data set.
Correct.
Plotted. So
Correct.
this.
Yeah.
Okay. So if my training data set changes, my the
And
data
then
point that we'll consider again 3 only, but that 3 will be different.
yeah. Correct.
Getting? There is
Yes.
one is in your test data set, if you change that amount of test data set, then that k might change.
Yes.
Correct? That is one point. Now coming to train data set, when I'm saying k equal to 3, I need to consider 3 nearest neighbors. That's fine. But if my train data set is changing, the 3 neighbors will also change.
Yeah.
Correct? So that
Hmm.
NN is coming from training data.
Correct.
K is coming from test data.
Test data. Yeah.
Okay?
Yeah.
Clear?
Hmm.
This point is actually very, very interesting point. I found it. And when in case if you're giving interview and if they ask, I request I recommend you to bring out this point. I think
Correct.
they'll be very impressed. Okay, usually I have never seen this in most of the tutorials. Okay,
Okay. Okay.
so and always remember the k coming from test data set. If you change the k, test data set k changes, and train data is coming from NN coming from train data set.
Yeah.
Okay, that means what? If for test set 1 for a particular one first test set, if k equal to 6, if you change the test set, this might become 4. The k value might change as you change test data set.
Understood. Yeah.
Right. So now I said, right, so there is one concept called as cross validation.
Yeah.
The reason here is now from this point only we will study that. So that means what? When I'm saying, so you are having that, this is very, very interesting point, you see. So I am saying this is my test data set. If it is 10, or for example, this I am considering this 10 data points. For this, there could be some k which is working.
Yeah.
I consider this last. For example, if I consider randomly when you are dividing like 80, 20, 10, 90, randomly divide, right?
Correct.
For example, first 10 goes into test data set
Hmm.
and last 90 goes into training.
Yeah.
Now, this test data set is different from this.
Correct.
Now, if you pass this, K equal to 3 might give different accuracy.
Correct. Correct.
Correct? So that means what? Changing the test, not only adding more amount, but even if you use 10 only, but a 10 set of this 10 are different from set of other 10. So if you
Correct.
change the test data set, the K is changing.
Correct. Got it.
Correct? Clear?
Yeah. Yeah.
So that's why in this particular algorithm, we cannot just blindly split the data and say, hey, this is my trained data, this is my test data, I tested on test data, I got accuracy, that's fine.
Mm-hmm.
Correct?
Okay. Yeah.
Because the question is, if right, while dividing, we use a random state.
Yeah. Yeah.
Random state, so it randomly divides.
Correct.
But when you change the random states to some other number, you will get some other value.
Yeah. Yeah.
Correct? Random state K equal to 40 or some any number you take. If you are using 40, you will get some accuracy. If I am using 20, my trained data set is different from your trained data set. My test
Correct.
set is different from your test set. So my K
Correct.
will be different from your K.
Yeah.
Getting?
Correct.
You understood the
Understand.
logic?
Understand.
Correct? So that is the reason.
Mm-hmm.
That is the reason what we will do here is, instead of falling into this trap, like dividing into, we use a concept of cross validation.
Okay.
Okay. So in that, what we will do here is,
Mm-hmm.
this is my whole data.
Yeah.
Okay. In that, initially we divide something into training first, some amount into like, let's say 80% training, 20% test. Okay.
Yeah.
But as of now, we are doing this. Okay. But now what we do here is, in new data set, so we take this. Okay. It's called K-fold cross validation.
Okay.
It's a cross validation, but
Mm-hmm.
usually it's called K-fold cross validation.
Okay.
Are you on track?
Yeah. Yeah.
Okay. So this, don't get confused with K. Okay. In ML,
Mm.
right, you will come across K many times. Here in K-fold cross validation, K is different. KNN is different.
Yeah.
KNN clustering is different. Okay. It's a hyperparameter. So that means what? Now you understood the reason. We cannot simply divide into train test like
True.
that.
True. Yeah.
Okay? So what we'll do here is, there is a concept called as cross validation. Okay.
Mm-hmm.
And K-fold means K is any number. Like if K equal to 3, it's called threefold cross validation. That means what? That in this training data set, okay,
Mm-hmm.
we will divide into 3 parts.
Okay.
Part 1, part 2.
Okay.
First part, second part, third part. That will become threefold. When you say fivefold, then it will become divided into 5 parts. That's it.
Okay. Okay.
Then what we'll do, you'll take this.
Mm-hmm.
Then first
Each.
we'll consider 2 parts as training data set and we'll leave 1 part as for test.
Okay.
Okay. We'll generate a model.
Okay.
Then 2 and 3 will become training. 1 is for test.
Okay. Then 1 and 3 and 2 will be the
And
test.
1
Okay.
and 3 and 2. 2 will be
Okay.
test.
Mm-hmm. 3 folds. Okay.
3 folds. Okay. That means 3 times models you will train.
Yeah.
From this 3, you got 3 models.
Mm-hmm.
Model 1, model 2, model 3.
Yeah.
Got it?
Yeah.
Now see, interesting what happens. Now you are having a test point.
Mm-hmm.
You pass to M1.
Yeah.
Okay. It will give you one prediction. One will give you only one prediction.
Correct.
Either it can give you 0 or 1.
Yeah.
It gave 0. If this is giving 1, if this is giving 0, you will go by the majority.
Okay.
So the value is 0.
Okay.
Here also, again, deliberately, we are not going for even.
Okay.
Because if you are having M4, we can use fourfold. If you use M4,
Correct.
it's also giving 1, then again 0, 0, 1, 1.
Yeah.
Getting?
Yeah.
Logic?
Understand.
So we'll go with 5-fold, 3-fold usually.
Mm-hmm.
Okay. So now, earlier what happened? Earlier we had only one model. So we pass it. Only that model, based upon its training data, it is doing the majority. And for that, we consider some rules, like it should not be odd, it should be something. And then based upon that, finally it will give you one prediction, 0 or 1.
Correct.
Fine. The problem is we cannot directly use training or test because of this important point. The K is dependent on the test data and NN is dependent on the training data.
Okay.
Right? For K, if you're changing, it is changing. That is fine. NN is coming from training data. So you can also argue like this. Hey, you are saying you use some random set 42 and you got 80% training data. Okay. And you are using prediction for this training data. But if I use some random set K equal to 20, my training data will be different from your training data.
Correct.
So my predictions, obviously the nearest neighbors will change, right?
Correct. Yeah.
So overall everything will change. So then also we cannot use. So that's why here the main goal of the main idea of cross validation is we will give chance to every part to be a part of training phase and also to be a part of test.
Testing phase. Yeah.
Agree?
Yeah.
One is also becoming training test. 2 is also becoming training test. 3 is also becoming training test.
Yeah.
So you cannot argue like we are not doing any injustice to any of the data set.
Yeah.
Right? From that, again, this is important. Don't think again we'll get only one model. We'll get 3 models.
Correct.
First 1 and 2. See, this model is, you can call it as 1, 2, 3. That means what? 1 and 2 are training, 3 is test. Okay. This is 2, 3, 1.
Yeah.
Okay. And this is 1, 3, 2.
Hmm.
Okay. Now, when you are passing a new input, earlier how we passed to one model and model is giving 0 or 1, here we'll pass to 3. First we will pass.
Yes.
Ultimately, the model will give you only one prediction, 0 or 1 either.
Correct. Correct.
Let's say this gives 0, this 1, 0. For example, best case, if all zeros, all ones, then there is no need of any thinking. Either it will be 0 or 1.
So this last test is the norm. I mean, it should be the same for all 3 models.
Correct.
Yeah.
Yes. Correct. So the same test point you will pass to 3.
New data, new test data.
Yeah, correct. If you go to this example, the Titanic example, so here, yeah, so here you will take this first row. Okay, you will take this first row, and earlier you were passing to only one model, right?
Correct. Now
So
we need to
like
pass
this,
the 3.
like this, you are having 3 models.
Correct.
And 3 NN, that means nearest neighbors are different.
Yeah.
The training data are different.
Correct.
Right? So you will take this test point. Let's say this is test point 1. You'll pass here test point 1. You'll get a prediction. Again, same test point you'll pass here, prediction. Same test point you'll get prediction.
Yeah.
Based upon, obviously you're having 3, so 1 should be majority.
Correct.
If all are zeros, fine, 0. All are 1. But if it is very different, there should be 1 majority.
Correct.
Then that will be the outcome of this test point.
Okay.
Getting?
Yeah. Understand.
This is called cross validation.
Yeah.
So if you're having 5, then
5
1, 2, 3,
parts.
4. Okay. Then 4 parts will become training.
1 part will become test.
1 part will become test.
Yeah.
And each part will take the chance of becoming test.
Correct.
Then you will have how many? 5 models?
Correct.
Model 1, 2, 3, 4, model 5. Then this test data set will be passed to this.
Yeah.
Each of this will give one prediction. And
Okay.
majority you will take, that will be the point.
Correct.
Clear? Any doubt?
No, Santosh.
Okay. Fine. So I would say that's for today. So just if you see, so we started with the basic and we understood the distance part, and the basic idea is just there is no training. It will just plot it and find out the distance and give you. Okay, that is how you can find out the where is this? Yeah, that's how just find out all the distance and pick the closest points. Okay, there are different distance you can try with. Fine. And usually there is no direct way to find out K. It is, we'll just explore. And how we will exploring is this way. So you will start with the range of K equal to, let's say 3 to 10. Okay. Now this for 3, now in the first step, 3 will be K equal to 3. And cross validation K equal to, let's say 5. Getting it is in the 2-step level.
Yeah.
First is in loop, inside a loop.
Yeah.
Initially for K equal to 3, now cross validation equal to 5. That means 5 parts it will divide, and each part 5 models it is generating.
Yeah.
Okay. And let's say you're having 100 test data points. Each test data points is passed to all these 5 models. And you'll get a prediction and you'll take the common like that. You'll do for all that 100 test data points.
Yeah.
Okay. And then you'll get some accuracy. And 100 test data points, you will get the corresponding predictions.
Correct.
You have the corresponding actual values. You will check and you will find out the accuracy.
Yeah.
Getting?
Yeah.
That is accuracy of K equal to 3.
Correct.
Then you will go for K equal to 4. but cross validation will be same. We don't change cross validation.
Correct. Got it.
Because that will not change.
So cross validation is fixed.
That is
On
also
what basis we will, I mean, go with cross validation? I mean, it
correct.
depends
So that
upon
is
data
also
volume or.
correct. That is also an hyperparameter.
Okay.
Okay. But usually it is not that tough, like k equal to 3. But this cross validation is usually k equal to 3, 5, 7, mostly 3 or 5.
Okay. In real time, how you have seen? I mean, whether in your project or what? Wherever.
No, in my project, it's actually a different scenario, like how we found out the k. Okay. So we plotted and we got the k equal to 3. Okay. But we don't use cross validation because slightly it is different. The reason is I will tell you, because in our case, what happened is the plans, let's say we consider last 3 years data set, we are having some plans. Okay. Now we want the similar persons.
Okay.
No, we want the similar persons.
Yeah.
Okay. But we just want the similar persons and what their features, but we don't want those plans because those plans are not available this year.
Okay, got it.
So every year the plans are changing.
Got it.
So what we'll do here is we will k equal to 30. We'll pick up the 30 people.
Numbers.
30 people and we'll focus on the features.
Okay.
Okay. What the features, like what the premium, etc. Okay. And those will try to, and we also have this year, current year plans, which the company is offering.
Okay.
We'll try to match
both this year. Yeah.
So these people who took these plans, okay. So in the current year, how are they, like, what are their nearest mappings for the current year? Okay. So it's not directly we are using those plans. So that's why we are not doing cross validation.
Got it.
We are using that to map to our current year, and then we are using two KNN models, like one KNN on top of other one. It's a different, it's slightly different. Okay. But in usual projects, we go with K4.
Okay.
Cross validation. Okay. K is 3, 5. You can just experiment with 3 and 5. Okay. Usually, let's say 5. Then now K equal to 4. KNN K equal to 4. Then again, you for 100 data points. Okay. See, when you are having K equal to 5, so first initially it will create 5 models.
Yeah.
And it will keep M1 to M5. Next, every data point from the test, it will pass and it will give you the predictions.
Yeah.
Okay. Because when you say K equal to 5, automatically 5 training data sets, test data sets are created and 5 models are generated.
That is just for creating number of models with different test and train data. Correct. But the outer loop 3, 4 are nearest points.
Nearest neighbors.
Model. Yeah.
Correct.
Yeah.
Correct. So this is to generate how many number of models.
Yeah.
Every part will get a participation in the test becoming a test data. That is. And once you have this model, so this M1, so let's say K equal to 5, it is generating how many models? 5 models.
Yeah.
M1, M2, M3, like that, M5. Now, each of this model, when you take this first data set and tell me, hey, tell me the nearest data points, it will ask you how many nearest neighbor points. You should say 3 or 4. That is this K.
Outer one. Yeah.
Okay. Now, if I say K equal to 4, then each model, and this is same for when you're looping through 4, here also 4 data points, it will consider nearest, here also 4, here also 4, 4, 4.
Yeah, it should be same. It should be same.
Because in that loop, see, for 3, you'll calculate for all 100 data points, calculate accuracy, put it aside.
Correct.
For 4, then you'll calculate all the data points from all the 5 models. You'll get accuracy. Again, for 5, you will come inside, and for each of 100 data points, you will calculate the accuracy from all these 5 models.
Correct.
Okay, these 5 models are fixed.
Fixed, yes.
Okay, these 5 models are fixed because once we have divided and created, right, these are fixed. But as per your K is changing, your predictions will change.
Yeah, got it.
Then you will take the best one. Okay.
Yeah.
Got it?
Got it.
Fine. So that's how you can find out the K, and there is no rule. Okay. And the iris dataset example, I will show in tomorrow's class. Okay. For example. Okay. Theory, there is not much theory actually. So we have discussed most of the things, the basic definition, pros and cons, okay, space complexity, time complexity. And also we have discussed overfitting, underfitting, K should be high or low, and what are the values, pros, cons, and range of K, and main important observation. Okay.
Yeah.
So mostly this much theory is actually enough for KNN part. Okay. And also we have seen what is the reason to, study cross validation, and what is the problem with the direct train test split. Okay, fine. So I think we are good with theory part. Fine. Tomorrow, let's see in the next session one cross validation along with the cross validation example. Let's see. Okay, whatever we discussed, right? So that we'll take a data set and we'll see how what is the cross validation, like if you do threefold cross validation, how three models are getting generated and how the data is passing through and how we are getting predictions and finally how we are getting the output.
Sure.
Okay, that code part will say, and after that, like every other model, it will also have some hyperparameters. Okay,
Yeah.
and if there are any assumptions, we'll see. And just if you are curious, you can go to sklearn KNN. Okay, and go here and you can just see these points. Okay.
Okay.
KNN was classifier, and there is one thing called as weights actually.
Weights.
So this we'll discuss when we are discussing hyperparameters. Okay.
Okay.
But I'll just tell you one point before we leave. Okay, the one interesting point, I don't know whether you got this doubt or not. For example, you are having data points here. Okay, this is one class one. Okay, and let's say this is class two. Okay, and now there is one data points. Okay, which is this data points. This is plotting here. This is my test
Okay.
data point. Okay.
Yeah.
Now if you see, yeah. So now if you ask, hey, these are my class, let's say 0, and these are my class 1.
Mhm.
This is my test data point. Now if you see when I say k equal to 3,
Okay.
can you tell me like what could be the output of my data point?
K equal to 3.
Yeah, for example, if you're getting confused, I will draw here. Yeah. Now can you tell me for this data point, if consider k equal to 3, what
Mhm.
will be my output class? Will it be 0
So
or 1?
it will be 0.
0. Why? This is 1,
Nearest to 1.
this is 3.
Yeah.
Okay. That is logical.
Yeah.
But if you think about it, it is very, very close to this point.
Correct.
Getting?
Correct.
A equal to 3. Okay, fine. This is one nearest point. This is second nearest point. This is third nearest point. That is fine.
Hmm.
But you should also consider this is very, very close to this.
Correct. Correct.
Even though it is having only in k equal to 3, only you're having 2 pinks and 1 orange.
Hmm.
Okay, that's why you're saying this will belong to pink color. Okay,
Correct.
just I'm saying colors. Okay,
Correct. Correct.
that is fine. But somewhere if you see it is very, very close. That means almost it is same as orange.
Yeah.
So it is having more probability to become this orange point
Correct.
than these
Correct.
two, because if you see the distance are very far.
Yeah.
But if you consider a circle of 3, yeah, these two are getting more weightage because they are counting more.
Yeah.
But this is only 1, but still it is very, very near.
Yeah.
Correct?
Yeah.
So if you think in a way, there are also chances that this point classification could be orange,
Orange.
0, which is 1
Yeah.
instead of 0.
Correct.
Getting?
Yeah. Yeah. Understand.
You understood, right?
Yeah. Yeah. Yeah.
Yeah.
Understand.
So that means, yeah. So because these are very far, so that's why we have something called as weighted.
Okay.
That means what? So when we are discussing hyperparameter, we'll see. Just I want to tell you. That means what? In that case, what we'll do, instead of directly going by the distance, instead of directly going by the points k equal to 3, we'll also calculate the distance.
Okay.
Okay. That means if it is very nearby, we will give more weightage to this point.
Okay.
If k equal to 3, we consider these 3 points. If very nearby, we'll give more weightage. If the bit far, we'll give less weightage. So in that case, there is a probability that in k equal to 3, the prediction of this point will become 1, orange, instead of
Yes.
pink, because we are giving more weightage, and that is also logical.
Yes.
Correct?
Yeah.
Fine. So that is just one point I want to discuss. Yeah. As I said, we are good with the theory part, and we'll see if there are any points I missed in covering the theory. If there, we'll cover next session, or if else, we'll see one code example, and we'll discuss hyperparameters. And with that, I think we should be good with KNN.
Okay.
Okay.
Yeah.
Okay, man. Thanks. Any doubts?
No. Good.
Thanks. Bye.